Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.2, Problem 33. This is Section 2.2, Problem 33. It says solve the matrix, and we have a matrix. The top row is 2, 1, negative 1, 2. The middle row is 1, 3, 2, 1, and the bottom row is 1, 1, 1, 2. So, to solve a matrix like this, the very first thing you want to do is get a 1 in the upper left position. Right now it's 2. So, in this case we have two options, or even three options. We can swap rows, and we could either swap row 1 and row 2, or row 1 and row 3, and that would make a 1 show up. Or a third option that I don't think is as good is I can multiply the top row by 1 over this number, 1 over 2 in this case, which would make some fractions. I'd have 1 over 2, negative 1 over 2, the 2 over 2 would reduce to 1, which would be okay. And I'd get the same answer either way. So if I can get the same answer without having fractions, of course, I would prefer to do that. So in order to complete step 1, which is get a 1 in the upper leftmost position, I'm going to choose the option where I swap rows. And I really could swap with row 2 or row 3. I'll pick row 2, it's closer. I don't have to move it as far. It doesn't matter when you're writing it down, but off to the side, let me set up my new matrix. Next to it I'm going to write swap R1, comma, R2. And what was R2 is going to come up. 1, 3, 2, 1. What was row 1 will go down to row 2. 2, 1, negative 1. Don't forget the negative. 2. And row 3 can stay right where it is. 1, 1, 1, 2. So step 1 is complete. I have 1 in the upper leftmost position. Step 2 will be to zero out the other values under that 1 that we just got. So the 2 will have to become a 0, and the 1 under it will have to become a 0. So let me set up the next matrix. And for my next matrix, row 1 can stay as is for now, because in this first column I don't want to change the 1. So that'll stay 1, 3, 2, 1. But now in the next row down, I want that 2 to become a 0. So I'm working in row 2. I'm going to set up an equation that begins with row 2. Row 2 equals some stuff plus the old row 2. My equation begins with row 2 because that's the row I'm making the 0. It ends with row 2 because it should end with whatever row it begins with. Now, what I initially call stuff is the row with the 1 in the same column as where I'm making the zeros. And notice I have two 1s here. I'm working off of row 1. I could actually use row 3, but you're supposed to use the 1 that's going to be in your final answer. And in the final answer, you're going to have 1s going along that diagonal. So I want to use row 1. And row 1 will be multiplied times the value I'm zeroing, so times 2, but opposite sign, so it'll be negative 2. So my equation is the new row 2 equals negative 2 times row 1 plus the old row 2. So that'll make a 0 there, but it'll change the other values in row 2. So the first position, negative 2 times row 1, I make a negative 2 when I multiply. Add that to row 2. So negative 2, positive 2, 0, which is what I want. That's good. Next, negative 2 times row 1. When I multiply times 3, I'm going to make a negative 6. Take that result, add it to row 2. So negative 6, positive 1. Negative 6, positive 1 is negative 5. Next, what happens to the minus 1? Well, negative 2 times row 1 will be negative 2 times positive 2. That's going to make a negative 4. Add that negative 4 to the next row down. So negative 4 and negative 1 add to negative 5. And finally, the last position, negative 2 times row 1 is negative 2 times 1. That'll be a minus 2. Add that result to row 2. Negative 2 plus positive 2. That adds to 0. So there's the first 0. Now, to complete step 2, I also want to zero the bottom of the first column, which is right now positive 1. So I'm going to set up another equation. The other equation will start with row 3, because that's the row I'm making the 0 in row 3. Row 3 will equal some stuff plus the old row 3. Again, if it begins in row 3, my equation must end in row 3. And what I initially call stuff is the row with the 1, which is row 1, times the same number that I'm zeroing out, but with the opposite sign. So in my matrix, I have a positive 1. In my equation, I have a negative 1. Also a 1, but opposite sign. One's positive, one's negative. So my equation is the new row 3 equals negative 1 times row 1 plus the old row 3. That'll make a 0 show up here, and it'll change the rest of the bottom row. So let's see what we get. Negative 1 times row 1. Negative 1 times 1, I'm going to make a negative 1. Add to row 3. Negative 1, positive 1. There's the 0 that I was hoping to get. Next position, negative 1 times row 1 will be negative 1 times positive 3. So when I multiply, I get a negative 3. Add that to row 3. So negative 3, positive 1. Negative 3, positive 1 will be negative 2. Next position, negative 1 times row 1 is negative 1 times 2. It's going to make a negative 2. Add that to row 3. So negative 2, positive 1. Negative 2 plus positive 1 is negative 1. And finally, the last position, negative 1 times row 1 would be negative 1 times positive 1. So I make a negative 1 when I multiply. Add the result to row 3. So negative 1 and positive 2. Negative 1 and positive 2 will be positive 1. So now step 2 is complete. Step 2 was 0 out those two positions, and they're zeros. So now I move to step 3. Step 3 is this position where I have the first negative 5 turn it into a 1. Swap rows if you can. Well, swapping rows isn't going to help me. So to get rid of that negative 5, I have to multiply row 2 times 1 over that value. So times 1 over negative 5. So let me set up the next matrix. And when I do that, the top row is going to stay 1, 3, 2, 1. In fact, I can leave a little bit of space for the middle row. The bottom row is going to stay for this 0, negative 2, negative 1, positive 1. Now, my new middle row. My equation this time will be row 2 equals 1 over the number that's becoming a 1. So 1 over negative 5. Notice I keep the sign too, times the entire row. And here's a good example. Notice when I make zeros, I'm adding 2 rows together. When I make 1s, I'm only dealing with 1 row. When I make zeros, opposite sign. I was doing a positive 1, I use a negative 1. When I make 1, same sign, negative 5, negative 5. If that's important. So 1 over negative 5 times row 2. 1 over negative 5 times 0, well, anything times 0 is 0. 1 over negative 5 times negative 5, I get negative 5 over negative 5. The negatives cancel, the 5s cancel, I get 1, which is what I want. I get the same thing again here, 1 over negative 5 times negative 5. So again, I get negative 5 over negative 5. Negatives cancel, 5s cancel, I get 1. And in the last position, 1 over negative 5 times 0, again, anything times 0 is just 0. So now step 3 is complete. Step 3 was make that position a 1. It's a 1. Step 4 is the other two values in that second column, the positive 3 in the top and the negative 2 in the bottom, have to become zeros. So let's set that up. I'm going to do another matrix off to the side. So now the top row, I'm going to make a new top row, and I'm going to zero out that 3. So I'm going to make an equation, which will start with row 1, because that's the row we're making the 0 in, row 1. My equation will be row 1 equals some stuff plus the old row 1. Right? If it starts with row 1, it must end in row 1. Now, what I initially leave a space for and call stuff is the row with the 1. So for this particular step, that's in row 2. The row with the 1 is row 2. And that row, row 2, is going to be multiplied times the number I'm zeroing, but opposite sign. So I'm zeroing a positive 3, so in my equation I multiply times a negative 3. So my equation is the new row 1 equals negative 3 times row 2 plus the old row 1. Now, what's that going to make for me? So negative 3 times row 2 initially is negative 3 times 0. That's 0. Add to row 1. 0 plus 1, 1. Next one. Negative 3 times row 2 is negative 3 times positive 1, so I make a negative 3. Add to row 1, so negative 3 plus positive 3, 0, which is what I wanted to get. Next position, negative 3 times row 2 rather. Negative 3 times row 2 is negative 3 times 1, which is negative 3. Add to row 1, negative 3 positive 2. Negative 3 positive 2 is negative 1. Again, pay attention to the sign. And finally, the last position, negative 3 times row 2 is negative 3 times 0. You get a 0 as a result. Add the result to row 1. You add 0 plus 1. 0 plus 1 is 1. So there's one of my zeros. Now, the next row down can stay. In this column, I don't want that to change. It's a 1. I want it to stay a 1. So I will just copy in 0, 1, 1, 0 for row 2. Now, row 3, I'm going to have to make an equation to make this negative 2 turn into a 0. So my 0 is going to show up in row 3, so my equation begins with row 3. The equation starts with the row where you want the 0. It will equal some stuff plus the old row 3. If it begins in row 3, it must end in row 3. What I initially call stuff is the row with the 1, it's row 2, times the number that I'm zeroing, it's a 2, but opposite sign. So my matrix has a negative 2 that I'm zeroing, so my equation will have to have a positive 2, right? Both 2, one's positive, one's negative. So my equation that will make the 0 where I want is the new row 3 equals 2 times row 2 plus the old row 3, positive 2. So do that equation. 2 times row 2, first position is 2 times 0. That result is 0, add that to row 3. 0 plus 0, 0. Next, positive 2 times row 2 is 2 times 1. That gives you positive 2. Add to row 3. Positive 2, negative 2, 0. Next, positive 2 times row 2 is 2 times 1, which gives you a result of positive 2. Add that result to row 3. Positive 2, negative 1. Positive 2, negative 1 is positive 1. And finally, the last spot is positive 2 times row 2 is positive 2 times 0. So that gives you a result of 0. Add the result to row 3, right, because that's what the equation tells you to do. 0 plus 1 is 1. So step 4 said turn the values in the second column in the top and bottom position into zeros, which we did. So that was step 4. Step 5, the value in the bottom, not the total bottom corner, but in the bottom of the third column, has to become a 1. Well, it is a 1. That's good. Saves us one step. So the final step, step 6, is zero out the other values in that third column. So the minus 1 on the top becomes 0, and the 1 in the middle becomes 0. So I will set up what should be the final matrix. I'm going to make a 0 in row 1. So I start an equation with row 1, because that's the row making the 0 in row 1. It will equal some stuff plus the old row 1. If my equation begins in row 1, it must end in row 1. Now, what I initially call stuff and leave a blank space for is the row with a 1. Now, here's where it becomes important. Notice, row 2 has a 1 in it, row 3 has a 1 in it. I used row 3 for my equation. How come? Because if I use row 2, it will make a 0 where I want it, but it's going to mess up this 0 here. You want to use the row with the 1 that's going to be part of your final answer. Notice the final answer, the ones come along that diagonal, so they end in row 3. That's why I use row 3. So if I use row 2, it could make a 0 here, but it's going to undo this 0 that I did in the previous step. So you want to use row 3. And to finish it off, that row 3 that I'm using gets multiplied times the number I'm zeroing, but opposite sign. So I'm zeroing a negative 1, so in my equation I use a positive 1. So my equation is the new row 1 equals 1 times row 3 plus the old row 1. Well, 1 times row 3. Essentially, my new row is coming from row 3 plus row 1. So I can go right across, row 3 plus row 1, row 3 plus row 1, row 3 plus row 1, right through. So the first column, row 3 plus row 1, is 0 plus 1, which is 1. The next column, row 3 plus row 1, is 0 plus 0, which is 0. The next column, row 3 plus row 1, is 1 plus negative 1, which is 0. And the last column, row 3 plus row 1, is 1 plus 1 more, which is 2, positive 2. So one last value to zero out, which is the 1 in the middle row. And I need to make an equation to make that turn into a 0. So my equation will begin with row 2, because that's the row we're making the 1. Making the 0 in row 2. Row 2 will equal some stuff plus the old row 2. Right? It begins in row 2 because that's the row making the 0. It ends in row 2 because it needs to begin and end in the same row. Now, the area where I just initially skip over and call stuff is the row with the 1, which is row 3, times the number I'm zeroing, so times 1, but opposite sign. In my matrix, I have a positive 1 now, so my equation must have a negative 1. So my equation is the new row 2 equals negative 1 times row 3 plus the old row 2. So let's do that equation. So negative 1 times row 3. Negative 1 times 0 is 0. Add that result to row 2, 0 plus 0, 0. Next one, negative 1 times row 3. Negative 1 times 0, that's 0. Add 0 plus 1, it's 1. Next spot, negative 1 times row 3. Negative 1 times 1, you'll make a negative 1. Add to row 2, negative 1, positive 1, 0. And finally, negative 1 times row 3 is negative 1 times 1. Again, you make a negative 1. This time when you add to row 2, you add plus 0. So negative 1 plus 0. Negative 1 plus 0 is negative 1. And the bottom row is good as is. You just copy it in. 0, 0, 1, 1. And now I've completed the matrix. I have all the 1s and 0s I need. So the last column tells me my solution. The top row says that x is equal to positive 2. The middle row says y is equal to negative 1. And the bottom row says that z is equal to positive 1.